Already we have covered HDFS in detail, and then we covered how to run MapReduce job and what is difference between classic and yarn. I have covered theoretically, and now we will start with what is map task and reduce task. This is more important. Second one is might be important for the interviews. Other than interviews, you don't need to worry much about what is difference between classic and yarn, what are the demons in classic, what are the demons in yarn, which I have answered as part of the last class, is not very important apart from the interviews. But what is map task and what is reduce task is very important. So I will try to explain the concepts behind it, and then as part of when we go to the next slide, we will understand how to plan our or how to design the solution for the business requirements using the MapReduce concepts. Okay. So I am going to whiteboard now. I am opening a tool. So for this, I will take the example of cards. As you guys are, most of you guys might be aware how playing cards look like. Playing cards, a deck of cards will have 52 cards, and it has two colors, red and blue or black. Red and blue or black. And the second one is it has four suites: spade, diamond, heart, and club. And then it has 13 pips. Okay, so pips are 2 to 10 and JQK Rs. So those are called as pips. So there are 52 cards in a deck, in a single deck. Let's say you have hundreds of decks, and first let us understand, hundreds and millions of decks. Okay, first let us understand, if you want to store real deck of cards in a big container. Okay, if you just store in one container, I have to use different item here. Let me see the size of it. Okay, yeah, size is fine. So if you think about it, if you just put it in a bigger container, all the deck of cards together, okay, all the decks together, then it will be very tough to divide for distributed processing. If you want to get count of cards by color, or count of cards by suite, or count of cards by pip, okay, it will be very tough to get all the cards and start dividing them and get the count as quickly as possible. So from the HDFS perspective, instead of storing as one container as in regular file system, we are actually dividing two blocks of size 128 MB, which means let's say 100 decks or 1000 decks, and dumping into different containers. That is HDFS portion of it. Okay. Now once you dump the 100 or 1000 ducks in different containers, if someone want to process the count of cards by pip, first we have to categorize the cards by pip. We have to divide the cards by pip, and then we have to get the count. So that is taken care by map. So map is nothing but a task which we will be developing. So there will be a program which will be developing as part of map by extending a class called mapper, where we will have the logic of getting the cards, which means reading the data from which is in a particular block, and then once we read the data, the structure of the record will be like this. You have color, sweet, and pip. There are three columns or three attributes for deck of cards. So color can be black or blue and red. So there are two colors. See, some decks will have black or blue. Some decks will have some decks will have black, and some decks will have blue. And then you have red. Red is common. This black or blue will change based on the cards you are trying to use. And then sweets, as I mentioned to you earlier, heart, club, etc. So heart, club, to us. So there are different types of pips. So like that, each container will have many cards, because we are actually storing 100 or 1000 decks in it. So the responsibility of the to count by pip effectively, first you have to group the cards by pip. Each container will have cards of all types, of all pips. Okay, so hence this map function has to read the data from the HDFS, which means get the cards from the container, and then he will get each card one at a time, and then he has to see the pip, whether the pip is 2 or us or J or Q or K, whatever it is, and then he has to group all the cards. Whatever cards he get, he has to group by pip. So he will get the all the cards by pip. So all the cards with pip 2, all the cards with pip 3, etc. Similarly, there will be another map function who will do that. He will actually get these cards, and he will actually group all the cards by pip 2, 3, 4, etc. Similarly, there will be another map person who will behave like a map task, who will read the data and transform the data in such a way that data can be grouped by the grouped key here, which is pip. Okay, so that is the logic which will be implemented in the map function when you actually develop, and that will be executed when we actually submit the MapReduce job. So to satisfy this, you have to develop the logic when you actually develop the program. Whether you use Hadoop MapReduce, or whether you implement MapReduce in any other technology. A lot of technologies support MapReduce APIs, such as Spark and MongoDB, Cassandra. Everyone have their own MapReduce API to develop this logic, but the performance will be different. MapReduce is much better than Cassandra and MongoDB, and Spark is better than MapReduce in some of the cases. But what you need to understand is the map logic should include reading the data from the file system and then apply the transformation on each row, because he will be reading one record at a time. This person will get one card at a time. Okay, and then he will see whether what pip it has, and then he will group the data, and then after grouping, there will be reducers here who will get this input, and then taking each group, he will actually perform the count to confirm how many 2s are there, how many 3s are there. So this guy will approximately get half of them, and this guy will approximately get half of them. So there are 13 pips. So this guy might get 6, and this guy might get 7. So this reducer, this is mapper, and he will get all 2. Let's say he get all 2, 3, 4, 5, 6, 7, and this guy get rest of the stuff, such as 8, 9, 10, J, Q, chaos, and then they will actually go through the pip. So here, and then once they go through the array for the pip, or the group of a corresponding pip, they will start counting it. Now it is very easy. He don't need to categorize or group. Once he get the count of all 2s, he will just write the output saying 2 is 3 million, similar 3 is 4 million, whatever the number. So this guy also go through the pips he got, and he will count it, and then he has to write this output to HDFS. So the bottom line that you need to understand is map will actually read the data, map function going through the map logic which you have implemented will actually read the data from HDFS, apply row level transformations such as converting each card, which is like this, to in such a way that it can be grouped easily. We will see how it is grouped when we actually get into the programming. I will show how to program this requirement also. Okay, he will apply the transformation for each of the record so that the data can be grouped easily. That is the responsibility of the map task, and the reduce task will take care of these pip and its group, and he will perform the aggregation here. So you holding this, he will actually perform the count for our case. Not only that, once the aggregation is done, whatever is the output, his responsibility is to write this data back to HDFS. So this is HDFS, and we want to store the data in HDFS. This reducer will actually store it back to HDFS. So map will read the data, perform row level transformations. Reducer will get the output of the mapper and perform transformations such as aggregations, and then he actually writes back to HDFS. So that is the MapReduce typical programming and execution life cycle. Okay. So now the question is, now we will go to the question. Question is, what is map task and reduce task? As I have mentioned to you, map task is primarily to read the data from HDFS and apply row level transformations. Okay, you can only perform row or record level transformation in the map task. Okay, and then after applying the transformation, it will emit the output in the form of tuples. Okay, it will. So I will come back to this when we actually go through the programming. It's so the middle portion after applying the transformations is not completely accurate, and it will differ based on the framework. And I will explain how it is done in MapReduce framework when we actually get into the programming. Okay. For now, just remember that map task is to read the data from HDFS and apply row level transformations. A reducer task will take the output from multiple mappers. So here for 2, there is a group from this map task, there is a group from this map task also, and also there will be a group for 2 for this map task also. So this reducer will take in output of the multiple mappers related to the keys which he is processing, in this case 2 to 7, and then reducer will actually aggregate the data in that group and store the data back to HDFS. Okay, we will see this again as part of the developing the programs using MapReduce APIs. It's not couple, it's tuple. Tuple is nothing but a key value pair. Okay, and I will explain that when we actually get into the MapReduce programming in next slide. So what are the MapReduce daemons in Classic? So the MapReduce daemons in Classic I explained as part of the last class. In Classic you have job tracker and task tracker. Task tracker sends heartbeat to job tracker so that job tracker keeps track of the resource management. And then job tracker will actually submit the jobs to task trackers, and task trackers will execute in the form of map tasks and reduce tasks. Okay, and these daemon process job tracker will be running on one host which is considered as master, and task trackers will be running on all the hosts, all the slave nodes in the cluster along with data node. I have already explained as part of the last class, so I am not getting into too many details here. What are MapReduce daemons in yarn? So the master is resource manager, It could be on 1 or 2 nodes depending upon typical configuration or high availability configuration. And then each of the data node or slave node, each of the slave node on which data nodes are running, you will find another daemon process called node manager, which is primarily to process the data. What is application master? I have explained this also as part of the last class. This is the major differentiating factor between classic and ER. Classic does both. In classic, the master process, which is job tracker, does both resource management and also job management, which is a lot of overhead in a larger cluster where hundreds and thousands of jobs are submitted concurrently. Job tracker will become bottleneck because job tracker is taking care of both resource management as well as job management. Whereas in YARN, resource manager will take care of resource management, but resource manager does not take care of job management completely. Once resource manager decides, request has to go to the resource manager, then resource manager first creates application master and delegate the job management to application master. Once the job management is delegated to application master for each job, the application master might start on any node in the cluster, and then it will actually talk to the node manager to get the resources and execute the map tasks and reduce tasks. So the job management responsibility is delegated to per job application master. This application master will be created for each job. So if you run 100 jobs concurrently, there will be 100 application masters, one for each job, randomly running on any slave node in the cluster. So the job management is delegated to the node managers so that they can get a better scalability, reducing overhead on the master, which is which is termed as resource manager in this case. So resource manager and job tracker or node manager and task tracker are just the terms. So there is a question here. Yes, map and reduce tasks are executed at every data node. That is right. And those are executed by node manager or task tracker depending upon the framework you are using. Okay. When it comes to classic, job tracker will control this job execution. When it comes to YARN, it is per job application master which will take care of job execution, means the job management at the higher level. Okay, and the next question is, what is job history server? So when we actually submit jobs in YARN, so this application master, this job history server is concept of YARN. You don't see job history server in classic. So there is one more question. The question is, doesn't running application master on slaves create resource contention for data node and name node daemons? No, it will not. It will not create contention because this application master will be of same size as a map task or reduce task. It does not take a lot of resources to monitor an individual job. Okay, it only takes care of job management. It will not execute. So it will take as few resources as the individual map task or reduce task. Okay, in that context, instead of, let's say a job is taking 10 tasks to execute in classic, when you submit in YARN, the same job will take 101 tasks. One task will be for application master and the other 100 tasks will be the map tasks and reduce tasks. And even the application master will take lesser or same amount of resources as with the map task or reduce task. So there will not be any contention. The responsibility will be only to manage the job which is running in the distributed fashion. Okay. So let me review the parameters. so that you understand this in a moment. I will go back to job history server in a moment once I show the parameters, memory settings which will actually control all these things. Okay. So, there are memory configurations at container level in ER. When I say container level, the container could be application master, the container could be mapper, the container could be reducer, the container could be non-MapReduce related tasks also. So, for, a container in the yarn world could be anything. Okay. So, at yarn level, if you go to the memory settings, you will see, 1 minute, memory MB. Okay, so you can see it here. This is yarn node manager resource memory. So from each node, I am using 8 GB for all the containers. This is not just for one container. This is for all the containers for each node we have. So we are allocating 8 GB of RAM for our MapReduce framework using yarn. Okay, if you go to HDFS and if you look into memory settings, typically HDFS only takes 1 GB memory to run the data node, not more than that. Even if you use 64 GB machines, 1 GB only will be allocated to HDFS, whether for data nodes especially. For name node, there won't be any contention. To answer your question, name node will not be impacted at all because this application master is created on the slave nodes. Resource manager also will be running on the different master than name node. So name node will have 0 impact. When it comes to data node, typically we give 1 GB RAM or 2 GB RAM, not more than that for each of the data node. Okay, and then we are giving in this machine I am giving 8 GB. On a 64 GB machine, probably will be giving 55 GB or 56 GB for MapReduce framework on each of the node. So this is overall memory that is allocated to, sorry, not MapReduce, to yarn on each of the node. Okay, and then there is another memory setting called scheduler. These are not very important at this level. They are, in general, they are very, very important. You have to understand these things. But at this level, they are not very important. Probably in the course, I will not be covering these things in detail. But as he asked the question, I am trying to show this. If you still have questions, you can actually explore these in detail, or you can ask in the Q&A time. Okay. So now you can see that there is yarn scheduler minimum allocation MB and yarn scheduler maximum allocation MB. Here we will specify for each task or for each container. The container can run map task. Container is yarn term. Okay, so the container can run map task. The container can run reducer task, or the container can run some non-MapReduce framework also. Okay, but let's limit ourselves to MapReduce. Here the container means map task or reduce task or especially map task or reducer task, not the application master. I will show the application master details in a moment. Here we are saying the minimum allocation is 1 GB and maximum allocation is 1 GB. And also to execute each of the tasks, we are saying the minimum course and maximum course, which are 1 and 1 each. So in this case, as the minimums and maximums are same, on this 8 GB machine, based on the memory, let's say this also have 8 cores on the machine. So 8 cores memory and 8 GB memory and 8 cores CPU or 8 CPUs. Okay, and then we are allocating memory of 1 GB for each task and 1 core for each task. So there can be 8 map tasks or reducer tasks that can run on this machine. Okay, so here I have defined maximum as 4. If it is, let's assume that it is 1. So we have maximum virtual cores or minimum virtual cores as 1, and minimum memory and maximum memory as 1 GB. So we can run 8 concurrent tasks at a given point in time. On top of that, there are memory settings related to application master. Okay, here application master also we are giving it as 1, and V course also we are giving it as 1. Okay, so using these resources, it will create the application master on any one of the nodes in the cluster, and this will take care of our MapReduce jobs. Yes, compared to classic and ER, there will be a little bit of additional overhead on the cluster, but as it is distributed, the impact will be minimal. So what will be that additional overhead? As he identified, Pramod identified, let's say you run 10 jobs, which takes 10 tasks on average. Okay, it only takes 100 MapReduce tasks to execute on the cluster using classic. When it comes to yarn, each job has to have this additional process for application master. So instead of using 100 tasks to complete the job, now it has to have 110 tasks to complete the job. 10 of them are for application masters, 1 for each job. So that overhead will be there, but as it will be distributed on the cluster, it is not that bad. Okay, I hope it answers your question. If not, I can explain it further because it is very important to understand this. Okay, now we will go to the job history server. First, so if you still have questions, just focus on these memory settings from YARN and HDFS, you will understand. So if you click on YARN, if you go to the status summary, on top of node manager and resource manager, there is a component called job history server, and it is running only one. So when I configure, I have configured one job history server, and it is actually running on, let me go to the instances. So click on this one and it will take you to, yeah, this is the one. So this is the IP address on 243, which I have designated as master. I am running this job history server. So why we need to have job history server? So for that, let me run one job. So there is the alert. Let me see what is going on. One of the data nodes is in bad health. Which one is it? It's 246. Let me fix this. Probably, otherwise it will create issues later. Okay, once I fix it, I will explain. I don't know why it is taking 81%. I will check it later. Better to run this command hdfs hadoop fs expunge. So expunge is the command to clear the recycle bin. Okay. So anyway, we are talking about job history server. For that, I need to run the MapReduce job, and I'm running this word count program. Okay. Okay, this is the jar file name, user lib hadoop mapreduce.jar. Word count is the application which I am trying to run, and then this is the input path, random text writer, and this is the output path. Okay, and hit enter. Now it will start the MapReduce job. So if you see, it has created a URL. Okay. For this, I have to actually use tunneling because I am using private IPs to access the cluster. So I am using SSH tunneling. Don't need to worry about it at this time. It is not relevant to the course. This is the workaround for the feature in AWS, the tunneling concepts. Okay, now I can access that IP address, and if you see, this is actually going to the resource manager web interface. Okay, so resource manager in Yarn will have something called web interface. Okay. This is not the one. Yeah, this is the one. So I was using the wrong one. Yeah, now it is working. So while the job is running, it will look like this. If you look into this URL, it is using 8088 port of resource manager. Okay, so this is called as resource manager web interface, and then if you see, it is actually providing proxy to the URL. Proxy means so in a distributed environment. Okay, when the jobs are running on multiple servers, instead of providing URL for each of the server, we can set up a proxy for a centralized server. In this case, resource manager itself is acting as the proxy for this URL, which is provided for the web service running for the application master. So when the job is running, it will be running on one of the nodes in the cluster. The job will be running on the cluster. For that job, there will be an application master. Okay, and that application master is running on this host, 248 host. Okay, so to get the progress of the job, we have to access the application master service. Okay, but these application masters will be running on multiple hosts in the cluster. So the IP addresses for each application master will be temporary, and it will be on multiple nodes in the cluster. For that reason, they have set up this concept called proxy. So proxy is providing a centralized URL mapping to multiple URLs that are supporting web service or web application running on multiple hosts in the cluster. So these application masters for each job can run on multiple hosts in the cluster. That's why they have created a proxy. So when the job is running, we can access it using the proxy of the resource manager. Okay. Once the job is done, the application master will dead. When the application master will dead, the URL will become invalid. Okay, because the web service also will be, the web application associated with the application master will be killed after application master is killed, when the application master is killed. So you no longer can access that application. For that reason, they have introduced a concept called job history server. So once the job is completed, okay, as of now job is running, it's 22% complete. Once the job is completed, the same URL will redirect you to job history server. Okay, job history server is another web application which will give you the details of the already completed jobs. Okay, the data which is required for showing these are in the log files, and these logs will be stored in HDFS. Okay, So we will see that once it is complete, we will see that, or I can actually kill the job, okay, because it will take time to complete this. Job list is the command which will mapred job hyphen list is the command which will list all the jobs that are running currently, and we can kill saying mapred job kill and the job ID, and the job will be killed. It will take a while to kill the job. Now the job is killed. Now if we refresh this one, it will automatically take to a different port number. Here you can see the port number as 19,888. It is the job history server port number. Job history is also running on 243 where our resource manager is running. So the IP address didn't change, but the port number is changed because job history is supported by a different web server or web application. Okay, there will be a software process for job history server which will be up and running, which can hear on this port number 19,888. And also, instead of having proxy blah blah blah, now the URL also changed, something as job history job blah blah blah. Okay, so now this is actually getting the details from the job history server once the job is completed or killed. And to render this page, it has to access information which is stored as part of the logs for the given job, and those logs will be stored in HDFS. So so the main thing which you need to understand is, once the job is completed, the logs will be copied into HDFS, and using that HDFS location, job history server can provide you web interface for each of the job on 19,888 port number. So you can access the details of the job using the job history server. So job history is a MapReduce only concept. When you configure MapReduce and when you run the MapReduce jobs using the job history server, you can access already completed jobs. While they are running, you have to use the proxy on the resource manager. When the jobs are completed, once you want to start looking into the history, you need to use the job history server. And for you, it doesn't actually make any difference. So let me go to the resource manager web interface now. The only reason why you need to understand is sometimes administrators might not configure job history server. When they don't configure job history server, then you will not be able to see the details of the job when the job is completed. At that time, you have to negotiate with the administrator saying that job history server is not configured, please configure it. Okay, so if you this is the actual resource manager web interface, which is homepage of the resource manager web interface, which runs on 8088 port number. And here, if you see, it shows all the jobs that are executed so far. Okay, and all the running jobs will be here. And if there is any running job, you can click on that, and it will take you through the proxy and get the details of a particular running job. But for the completed jobs, okay, you can actually click on history here. Okay, so even for the running jobs also, here it will say application master. Now it is saying history because this will redirect you to the job history server. If it is using application master, it will redirect to the application master through proxy. The URL will not change. The URL, IP address, and port number will be same for all the links here because of the proxy. But once it is completed, everything is supported by one web service called job history server, and when you click on this, it is smart enough to redirect you to the job history server. So as a developer, while accessing, it doesn't make much difference, but only thing you might get into issues is if job history server is not configured properly, then you will see container not found as some sort of not found error here. At the time, if you cannot see this, that means you are not able to access the job history server. You have to troubleshoot the issue if job history server is up and running or not. If it is not, then you have to talk to the administrators to get it fixed. Okay, so the question is, again, please ask the questions to everyone so that I don't need to repeat. Even if I forget to repeat, it will be smoother. Anyway, I will repeat this time. In production for Oracle like databases, they keep generation of logs to minimum. In Hadoop, generation of too many logs will deter performance in production. No, that is not correct. The reason is when it comes to Hadoop, it's a distributed computing framework where resources are used effectively to process the data in distributed fashion. And for that reason, even though logs are generated a little bit higher than Oracle, um, uh, as it is a distributed platform which will be supported using hundreds to thousands of nodes in cluster, in the distributed world, the overhead is negligible compared to Oracle, where you typically have 2-3 nodes in a cluster, even if you go with rack. So that is not the problem at all. So Raj have asked a question: how many jobs are stored and how old jobs are stored? Um, there could be some parameters to control that, but typically it can store as many uh, jobs as possible, because for each job the logs will not be of very large size. The size will be minimal. So even if you store millions of jobs over time, it shouldn't be a problem. So I'm not 100% sure. The question is not that important because we are using HDFS, and the storage will not get full because of these logs. So it is not very important to understand how many jobs and how old jobs are stored. And performance wise also, unless you start searching for the jobs to just get the recent jobs, performance will not be that much bad. Do we have any tools to analyze logs to find out number of rows processed in a day for entire batch, like that the run metrics? No, there is no out of the box tool, but when you get into the MapReduce APIs, there is concept of counters. So even when the job is ran, you can see different counters. Again, I will cover this thing as part of MapReduce programming in the next class. So here you can see the counter information. So after executing the job using the counter API, you can actually get these details for each of the job, and using this you can dump into any database and get a trend to the related jobs, how much it has processed for a job or for an application or in the overall cluster. It's not only how many rows are processed. The more relevant metric is how much data it has processed in terms of IO and etc. Okay, so you have to use APIs that are available on top of these counters to get that information. As per my knowledge, I don't know any such tool which can take care of this out of the box. It's very easy once you know the API. It's very easy to implement using Java. You can actually refer to definitive guide. There he actually provided code snippets about how to access this. You just have to look for the counters. Okay, so that is about job history server. Now how to troubleshoot the logs. So there will be a little bit difference between classic and yarn, but similar. So I will not be covering classic in this to troubleshoot the logs. Only the web interface will be a little bit different. But the way you troubleshoot is same. Okay, you just need to understand the terms, and then you will be able to troubleshoot. Now this is already completed job. Okay, you can go to the overview by clicking overview here, and then you can see that this job. Let me take another job which have a lot more tasks. Okay, let me use this. We can get the history from here also. So click on history. Okay, job not found. I think it is deleted. The reason why we could not see is I actually deleted the service and added these things back. That's the reason why probably it is not showing up here. Yeah, this one is showing up. I don't know why the other job was not showing up. So if you look into this, there are, let me go back to this page. So this is the job home page, okay, which is nothing but overview. In the overview, you can see that there are 40 map tasks used to complete this job. There are no reducers that are used, and all of them are successful. Okay, so you can click on this URL which is saying successful to take to the map tasks, or you can also click on map tasks on the left side. So if there are any failed, there will be tasks which are failed here, and you can click on that. It will directly take you to the failed tasks. So just click on that. It will filter out the failed tasks and it will show them. Okay, so once you get the tasks that are failed, hello guys, can you hear me? Is it only with one person or with everyone? One guy have complained that he cannot hear. Can you guys hear me? Okay, Vadhu, it's only related to you. Probably your internet might have been unstable. Okay. So I will proceed. You can get it the recording later. Okay. So once you click on the task, you will see this here, and then for each task there is logs. So for the failed tasks also you will see the similar page. Only thing is the state will be failed. Okay. And then you can click on logs and it will take you to this page. Okay. And if there are failures, you will see under standard error, and if you click on that, it will show the details about what have happened with respect to that task, and you can read the issues. So let me show some other job. I will come back to question in a moment. So I am going back to the resource manager API and opening the killed one now. Okay, in the killed one, go to the history. So if you click on these logs, this will only get the logs of the application master. Application master will not run any tasks such as mappers or reducers. It is only for the job management. So if you click on these logs, you will be able to see if there are any issues with respect to the application master. Okay, that exception is temporary, and this is how the application master logs will look like. So if there are any issues in the application master and if you have to troubleshoot, you have to go to these logs, and you can click here to get the full log and see what have happened in the life of the application master. Okay, so this is the life of the application master. You just have created the tasks on different hosts in the cluster, waited it to be completed, get the counters. So it's all about the job management. Okay, now we will go to the actual execution of the job by clicking on the history on top, and here you can see 31 are killed and 93 successful. 93 are successful because we killed in the middle. Only 124 tasks are created before it is killed, hence we don't see the details about the others. Now if you click on the killed task and go to the logs here, it will show the details about the log. It has got the it will show somewhere that it has got the kill request. I think it will not show here. Okay, it will show in the application master, because as it is killed, it might not know that it has got the kill request, but application master will know that anyway. So I am opening another one. Click on logs. You can see more details here. If you want to get the full log, you can click on this, click here for the full log, and you can see the details. So if you have to troubleshoot what have happened in case of failed tasks, you will see the details in the full log. So this is how you should use the logs to troubleshoot the issue. Okay, now let me take the question. So the question from Mohan is, when we run any Hive command, it internally runs MapReduce program, right? So it's possible to see that log of that Hive command. That is partially correct. Hive queries when run in MapReduce context will use MapReduce, but a Hive query can be mapped into 0 to many MapReduce jobs for a given Hive query. Some Hive queries need not run MapReduce jobs at all. Some Hive queries might run only one MapReduce job, but if you are using joins, aggregation, sorting, etc., a Hive query can translate into multiple MapReduce jobs, and you have to pick each MapReduce job and see into the logs to troubleshoot the issue in detail if the Hive query fails. It's not just one MapReduce jobs, but you might have to deal with many MapReduce jobs depending upon the complexity of the Hive query. And how often we need to check log of MapReduce of Hive command? So most of the errors will be consolidated, and Hive itself will provide the error. Okay, but in some cases the error might not be obvious to you. In that scenario, you have to get into the logs. So probably it depends upon the amount of jobs. Probably 10 to 20% you might have to get to the logs of MapReduce of Hive command. And also for performance reason also, you have to see how each job is performing, what are the disadvantages, so where it is actually taking a lot of time to troubleshoot that issue. From the performance aspect also, you might have to get into the MapReduce logs. Just focusing on the Hive logs is not enough. So the next question is, does it allocate default mappers or we can assign? We will get into that. I think I have the question here. No, it is not here. I will explain that, how the mappers are assigned and how the reducers are assigned when we actually talk about the MapReduce programming concepts next week, next class. The question is there any resources which provides us learn about interpreting logs? No, there is nothing like that. Only thing is you have to go here, and typically once you see the exceptions will be at the end. And first to begin with, you have to just focus on those errors, and then you have to focus on the other aspects from the performance aspect of it. Okay, so there are no resources except for Hadoop definitive guide, which can be overwhelming to you. But I will try to cover those things as part of the performance tuning offline of this course. It will not be part of this course, but offline of this course, I will get into the details about how to interpret these logs from the performance perspective. But at this time, it is more important for troubleshooting purposes in case of failures, and this is how you need to troubleshoot. You just go to the end of it, you will see the exception or search for exception or error, and typically there will be Java errors. It depends upon how effective you have written the Java programs. And the errors will throw the light about the issue. If you are not very good at exception handling in Java, then errors can be misleading. Errors or exceptions can be misleading. Okay. To answer your question, no, there is no proper resource which provides us learn about interpreting logs. You have to get it over time. It's not easy for you. Even if someone takes the interest and start explaining, it will be overwhelming to you. It comes with the experience more than classes. You have to practice, you have to go through these, and you have to understand what is what. Then it will make it a lot more clear. I am not able to get the login web page in CloudX Lab and as well as in my system. So when it comes to CloudX Lab, what you have to do is, so go to my lab. So probably it might be using IP addresses like this, 154, 153, etc. So depending upon the IP address, you have to replace it to the public domain. Okay, again, this is the limitation with respect to AWS, or it's actually feature, not the limitation. So then I have to look into it. Let's wait for some time. Let's finish off the question, and then I will take this question. You can actually share your screen and show it, and I will troubleshoot it for you. Okay. So now we will go back to the question. We will see one more question. How fault, or couple of more questions. How fault tolerance works in MapReduce? So fault tolerance, when these map tasks or reduce tasks fail. It can fail for different reasons. It can fail due to a bug, and it can fail due to hardware failures as well, which is not the bug created by the code. So when it comes to bug, it will fail. It doesn't matter. It has to fail, and job will fail, and you have to fix the bug. But when it comes to hardware failures, for example, when the job is running, if one of the node goes down, and if there are tasks associated with a job on that node, the job should not fail. Okay. For that reason, if it is classic, what job tracker or application master in yarn will do is, if a particular task is failed because of for whatever reason, it could be a bug or it could be a hardware failure, for whatever reason, what job tracker or application master, per job application master will try to do is, it will try to restart the task on a different node. So whatever data the task is being processed. So for example, let's take to this picture. Now let us say this guy died in the middle or hospitalized, and he cannot do the count. Okay, and he is in the middle of doing the count of all the deaths here. So what will happen is, a new person will come and he will try to do the same thing. So he will try to process the same data which is being processed by this person, but now it's a different person. From Hadoop world, it will be a new node, a different node in the cluster, which will take the responsibility of the job, and it will start from reading the data. It will not start where this guy has stopped. It is not possible. The new guy or the new node which try to execute this task will start from reading the data and redoing the processing all again. Okay, so this is called as retry. So for each map task or reduce task, when it fails for whatever reason, it will retry 4 times by default. After 4 times also, if it fails, then most likely it is due to the bug in the code. You have to troubleshoot the issue and you have to fix. In most of the cases, if it is hardware failure, the second attempt itself will be successful. In some cases, it might go to 3rd or 4th level. If it goes beyond that because of the hardware failures, that means there is the issue on the entire cluster itself. Probably it could be the network switch issue, network switch might have slowed down for whatever reason. So it could be the issue at the cluster level. If even beyond 4 retries, if it is failing due to some hardware issue, it is probably due to a bug in the code or due to some other major issue at the cluster level, which has to be troubleshooted and fixed. So by default, each task will be retried 4 times if it fails, and if it is successful within 4 retries, then it is most likely a hardware failure, and job will continue and it will complete. Okay, so this is how the fault tolerance is achieved by using the concept of retrying the tasks by redoing the work which is abruptly killed because of the task being killed for whatever reason. Okay, and from the perspective of MapReduce, it's a dumb computer and it doesn't know whether the task is being failed because of a hardware failure or bug in the code. It is very tough to build that intelligence into the system. So it will just retry 4 times if some issue happens. But if even after 4 times, if the task is not able to complete it, then the issue is with respect to the bug or a major issue at the hardware level. Okay, so when another question, when restarting, it has to take the replications of that block from a different data node. Yeah, it could be the replications, or if there are no replications available, if you are using only replication factor 1, it can even do the network IO where the block is on a different node also. Very good question. Typically, it will try to use the replicated copies and try to use the data locality when it comes to map tasks. Okay. And then what is split size? So for this, again we have to go to the whiteboard. So for this we have to draw. I'm not sure why it is changing to oily blender. I have to use pencils, fine point marker. Okay, so this is our cluster and we have data nodes or slaves, and each slave will have both data node and node manager. Okay, so when we actually create a 1 GB file with block size 128 MB, for simplicity purpose, let's say replication factor is only 1, so there will be only 1 copy. So there will be 8 blocks created for this 1 GB file, and these 8 blocks will be named as blk_1, blk_2, blah blah blah, and these will be stored in HDFS. Okay, so probably B1, B3 are here, B4, B8 and B2 are here, B5, B6 and B7 are here. So these 8 blocks are in these 3 data nodes which, that are part of our cluster. Okay, so earlier someone have asked how map tasks will be created. So the answer will be given now. It uses the concept of split size to determine the number of mappers. By default, the split size is 128 MB. Okay, who asked that question? Chandrasekhar have asked that question. Does it allocate default mappers or we can assign? So the answer is it uses split size. Now we are trying to understand what is the split size. Okay, so split size is by default. So there are 2 parameters. Again, go to the configurations. Make sure you make the habit of checking the configurations whenever you have the you don't have the clarity. It's very easy using Cloudera Manager or Ambari. You can just search for a particular string, and in this case we have to go to yarn, not the data node. So go to the yarn service, yarn plus MapReduce. If it is Ambari, I will show how to look into it from Ambari also. So when it comes to Ambari, you can see there is one service with yarn and there is another service with MapReduce too. Whereas in Cloudera, there is only yarn and MapReduce. So if you want to search for split size, it's a MapReduce concept. It's not yarn concept. Okay, so here I am searching for split. Okay, why it is not showing here? Probably it is using the default values and it is not showing here. Let me see if Ambari shows. So Ambari, again, it's a MapReduce concept. You have to click on MapReduce here. Go to configs. Yarn will have only the yarn related configs, and MapReduce will have MapReduce related configurations. So split. Okay, I think both of them are using defaults. So let me show the parameter. So default parameters might not show up here, show up in those web interfaces. Okay. So MapReduce dot input dot file input format dot split dot max size. So this is the parameter. Okay. So there are multiple parameters, max size and min size. So using this one, it will actually determine the split size. By default, the min size is 0. Okay, so we will see it here. So you can actually open this mapped default.xml file and then split. You can see here MapReduce inputs. Where is this? Yeah. So it says 0, which means actually let's see the description of it. The meaning is the minimum size chunk that map input should be split into. So the map input, whatever mapper try to process the data, it should be splitted into this minimum size. Note that some file formats may have minimum split sizes that take priority over this setting. So for some file formats, we can actually override it. Okay. So here, let me see if there is split dot max. No, there is no max. So when it is 0, what it will do is it will actually inherit the value from the block size. So depending upon the block size, it will decide the split size, and then it will actually start processing the data. So in this case we have 8 blocks, so there will be 8 mappers if the split dot min size is 0. If the split size split dot min size is changed to 64 MB on this data set, in that case it might use 16 mappers. If the split size is 256 MB, it will use only 4 mappers. By default, split size will be same as block size. So depending upon the number of blocks in the file, there will be number of map tasks. And if you want to customize the number of mappers, if you want to give more horsepower to your map tasks without changing the structure of the files, means without changing the blocks of the number of blocks of the file, then you can play with the split size. Either you can, if you decrease the split size, there will be more number of tasks which will be trying to process the data in distributed fashion. If you have higher split size, then there will be lesser number of map tasks which will try to process the data. So in this case, if it is 128 MB, there will be 8 mappers. By default, split size will be same as block size, and block size is 128 MB in this case, so it will take 8 map tasks. But if I change it to 64 MB, then there will be 16 map tasks, and if I change it to 256 MB, there will be 4 map tasks to process this data. Okay, and when it comes to developing MapReduce jobs, you have to implement something called combined file input format to play with this split size. With respect to Hive and all, you can play with split size, and you can actually change the number of mappers that needs to be used to execute a Hive query. Okay, so that is about split size. We will see the split size as part of the performance tuning offline of this course, but this is enough for you to understand what the split size is. So now we will start taking the questions. So the question from Pramod is, does number of map tasks also depend on number of cores in a CPU? So there are two things. One is number of map tasks that needs to process the data, and the second one is number of map tasks that can concurrently execute. Okay, so whatever you are saying is about number of map tasks or reduced tasks that can concurrently execute, that are dependent on number of cores and CPU. Okay, that is different. Here we are talking about number of map tasks that will take to process the data. So I will run this MapReduce job again so that it will make it clear. Okay, so we are trying to process the files in this location, random text writer. So first let us understand the size there. You can use ss-du-h, give the path, and it will give the size of the directory. Actually, let me summarize. So if you want to summarize, you have to use -s, s for summarize, and h for human readable format. Okay, and you can see it has 41.1 GB data set. Okay, so if I use 128 MB as block size, so it will take 34, sorry, not 34, 320, around 320 or 330 map tasks to process this data. If I use 64 MB, it will take 640 map tasks. If I use 256 MB as the split size, then it will take 160 map tasks to process this data. Using split size will only control how many map tasks that are required to process this data. And then we are talking about the execution aspect of it. For the execution aspect of it, irrespective of the number of map tasks that are required to process the data, number of map tasks and reducer tasks that are required to process the data. Okay, if we go to this resource manager web interface, on the top, it actually say what is the total memory of the cluster. We have 4 node cluster and each have 8 GB. So we have 32 GB and we have 16 cores. Okay, so based on these settings, it will actually determine how many map tasks that can run concurrently. Okay, now let me run this MapReduce job. Okay, so number of splits 360. So this is determined by the split size, which is 128 MB, because by default split size is same as block size. Now you can see why it is showing vCores total as 16 and it is using 32. That I will explore later. But here you can see that we have given 1 GB RAM minimum for 1 GB RAM and 1 GB minimum as well as maximum for our map and reduce tasks. I have reviewed the parameters earlier. So we have 32 GB, and I will come back to this later, but it is using 32 virtual cores, not the actual cores, but the virtual cores. You can see 32 here. So as we have defined 1 core minimum for each of the tasks, it is actually running 32 containers at a given point in time. So you can see there are 32 containers that are running. And if you open the job details by clicking on this application master, you can see map totals are 360. Click on the job. So you can see that there is a pending state, running state and complete state. So initially everything will be in the pending state, and depending upon the capacity of the cluster, which is 32 in our case, one will go to the application master. So we have only 31 capacity for this job because we already crossed the limit on our cluster. So for our job to run here, there are only 31 capacity. Okay, so those 31 will be running. Once they start getting completed, these 3 values will keep on changing. Pending, running, complete will keep on changing. Okay, you can see that. So this is how the memory, CPU and the execution will determine how many concurrent tasks can run at a given point in time. And what we were discussing with respect to split size is how many map tasks we need to use to process the data. Okay, those two are 2 different things. I hope it is clear now, Ram Kaushik. No, not Ram Kaushik, it's Pramod. So Ram Kaushik asked the question, how does change in split size affect the performance, sir? Is it preferable to have more map tasks? Again, it depends upon the logic which you are trying to implement. For example, as I have mentioned to you earlier, if we go back to this whiteboard, it's a very good question. If we go back here, we are getting 1 record at a time. In this case, each record is only 3 fields. Okay, there is some background noise. Let me mute everyone. Mute all. Okay. So in this case, we are just getting one record at a time, and we are trying to apply the transformation so that it can be grouped easily. That is the task which will be doing as part of the logic in the map. Okay. Sometimes a record can be much larger than just 3 attributes. It can be the complete file also can be treated as a record, or each record can be few megabytes. And sometimes you might have to run a lot of logic for each of the record. For example, if you try to implement chess in MapReduce, then for each move you have to do a lot of processing in memory. You don't have to process the data, but you have to think what should be the next move, and it takes a lot of CPU in the background. Okay, so it all depends upon the logic that is in the mapper to determine whether you want to increase the number of map tasks or decrease the number of map tasks. If there are too many map tasks, there is the overhead of creating the JVM and destroying it, and that overhead can be significant if your map task is not doing a lot of work. In that case, you can decrease the number of map tasks wherein the performance can be improved. But if your job is CPU intensive and if it takes a lot of CPU for each record, in that case probably it might be a good idea to increase the number of map tasks. So it all depends upon the use case. And the next question is it a hard rule that one mapper will be assigned to process one split size defined data chunk? It's not the hard rule, it's the implementation. So one mapper will be assigned to process one split at a time. Okay, that is the lowest granularity at which data will be processed. Split is the lowest granularity at which data is processed, and block size is the lowest granularity at which data is stored. And we can change these things on per file or per job. It doesn't matter, you can change those things. So before taking the next question, let us troubleshoot the issue. Who is that running into issue with respect to CloudX Lab? So if in future, please ping me and I will give you the presenter rights, and you can actually share the screen and I can actually see what the issue is. And also from next time, make sure you post this question in LinkedIn. Okay, that way I will respond to that. And also we can ask CloudX Lab guys also to troubleshoot the issue, and we will get the solution faster. All the technical questions, when you start practicing, post it in the LinkedIn. Make a habit of posting it in the LinkedIn. So who is that? Earlier complaining about not able to access the job logs. Okay, Raghavendra. So I will make you presenter. You can share the screen and you can show me, and then I will explain where the issue is. Okay. So let me open the participants. Raghavendra Singampalli, change role to presenter. Okay. Now you are presenter. You can share your screen. So to share the screen, go to Quick Start, and in the Quick Start there will be a share screen option, and then show me your screen, then I will explain. And while it is going, so we still need to get payments from many folks. So there are, sorry for the trouble that you have to go to bank and or you have to ship the check. So there are alternatives. You can actually, as most of you guys are in US, you can go to the YouTube channel, go to IT Varsity. And if you scroll down, there will be this support this channel section. You can click on the support. I have to change the owner. 1 minute, Raghavendra. I will start looking in. Okay, sorry. You guys cannot see my screen. I will explain it again later once this is done. Yeah. Yeah, you can run a simple job, and then we will see how to troubleshoot using the resource manager. Or you can actually go to the run the job. Then we will see. Actually, Raghavendra, you don't need to run the job. We will try to access the existing jobs itself. Okay. So for that, let me give you the IP address of the resource manager. So I have to go to yarn. So don't run the job. We can actually get the details without running the job also. So summary, I will give you the resource manager IP address in a moment. I will ping you in the chart. Okay. So this is the resource manager IP address, and then you can use you can go to browser and paste this URL. I am pasting the URL 8088. Okay, so I pinged in chat. So open that URL in the browser. Most likely it will fail because it is using the private IP address. Okay, sorry, I gave the wrong URL. There is no I in that. It should be http://IP. Yeah. It's colon 8088, not /8088. Okay, now it didn't work. Now replace the private IP with the mapping. So we are using 48, right? So go to IP mappings, and it is a.cloudxlab.com. So instead of using private IP, you have to go to the mapping, get the corresponding domain, and run with 8088 port number. I have pasted the URL, so you can just copy paste the URL from the chart. So wait for a minute. You will get all the jobs here. It will take a little bit time. Now you can actually click on the first one. So click on the application. So now you can click on the history. Wait. Why are you going to applications again? Click on the history. Click on the history in the middle, tracking URL. Okay, again it is giving the private IP here, which is 154. So job history is running on a different host, and you have to remove the ec2.internal also. So it should be c.cloudxlab.com up to ec2 internal. Yeah, that could be the issue why it didn't work for you before. Okay, now it is working. Now you can actually click on a map task. So click on the URL. Wait, yeah, you can go there. Click on the task. Click on logs. There is logs here. Click on logs. You can see the logs. You can click here you can also try clicking for the full log in the middle. You have click here for the full log. So that's the thing. So it is working. One thing you can do is you can update the hosts file with the public IP addresses along with the private IP, so that you don't need to replace that. So what you need to do is hello. Let me paste this to you. You just replace in the host file, and then you don't need to worry about these things. Okay, I hope you guys know where the host file in Windows is. If you are using Cygwin, you can actually open it as an administrator, and then you can actually run VI command itself to perform this. Okay, so this is whatever I have pasted is 5 lines. Make sure they are in 5 lines, and then you have to copy it to host file on your Windows system. Okay, you can do it later. It's not that easy. You have to open it as administrator, and it's a little bit tedious when it comes to Notepad. You have to open the Notepad as administrator, then navigate to your host file, then you have to update it. Okay. Once you update it, you don't need to change these things. It will automatically work. Okay, so I am taking as presenter now, and I will explain how to make the payment using YouTube before taking the next question. Okay, I am sharing my screen. Okay, so you can go to YouTube. 1 minute, okay. So once you log in, once you search for my YouTube channel, once you get into my channel homepage, you see this support this channel, and you can click on this support. If you don't have time to go to bank and issue the make the payment or send the check to ship the check to Raj, you can just use this, click on other, and you can pay whatever fee you have to pay, $200 or $250. I think for all the developers it's $200. So you just say $200 and then click on next, and it will ask the credit card information, and the payment will be done. Okay, and make sure you add a comment. That comment will only come to me, so it's a private comment, so that we actually can keep track of your who all have paid. Okay, so only we got 5 or 6 payments. Still long way to go, so please make the payment over the weekend. So I can take other questions if you have any. I will take one more question. Okay, then it seems we are done for today. We are going a little bit slow because we are actually getting into concepts. Yeah, go ahead, Mohan. I will wait. So the first question is, I guess, 1 minute. The first question is enough. Don't ask any more questions. Already there are 2 questions in this, and also Gopi have asked me 1 question, and then we will wrap up. I guess MapReduce logs are based out of Java program and it requires understanding of Java. No, to understand the logs you don't need to have understanding of Java. As long as you can interpret the exceptions, that is more than enough. Okay, any chance of looking logs from different language perspective like Scala? So logs are not Java, logs are just a text file to explain what is going on. So if you open these logs, don't think from the Java's perspective, think about logs as a text perspective. Okay, so in this case let me open one of the log with, from the successful. Sorry, this is not the one. Okay, so here I am going to logs, and you can see this is plain text. It is giving information saying what is happening in the map task, starting flush of map output. So you just need to understand what this is. This is nothing to do with Java. This is in general what is happening within the task. Okay, so even with respect to Spark, whether you use Scala or Python, there also the logs will be similar to this only. So the log, each log record structure will be, first it will have the timestamp at which this entry is generated, and then it will say whether it is info or debug, info or error or warning, and then probably this is the component which is generating the log, and then whether it is a map task or reduce task or some other thing which is generating this entry, and then what it is doing internally. So it's plain text. Don't think the logs from the Java perspective. Think the logs from as a plain English, and you don't need to worry about going through all these things. If there are exceptions, you just search for exception or error. Instead of info, there will be error or exception or warning. So look for those things, and you will be able to identify what the issue is. Okay, so the Java knowledge is not required to understand the logs. That is the first question. The second part of that question, any chance of looking logs from different language perspective? So no matter whatever language you use, we use log4j.properties only to control how the logs are generated. So the logs will be generated similar to this. So probably you might have to understand these terms if you want to get into other details. Okay, now the second question, since you were mentioning about MapReduce getting irrelevant, is the MapReduce logs getting deprecated in future? So MapReduce is becoming irrelevant. When I say MapReduce is becoming irrelevant, the Hadoop MapReduce as a concept will be relevant. So MapReduce is just a concept like RDBMS, and RDBMS is implemented in Oracle, in MySQL, in many other databases. Okay, so MapReduce is also a concept. That's why I explained it from the human perspective, so that you can relate. MapReduce is primarily a concept, and it is implemented using different programming languages and different execution frameworks. When it comes to programming languages, we can use Java MapReduce APIs, which work well with HDFS. We can use Spark transformations or actions to perform the MapReduce using Scala or Python as programming language. In MongoDB also you can actually develop the MapReduce programs. Okay, and then execution framework. So the MapReduce execution framework is becoming irrelevant. Okay, when I say MapReduce execution framework is becoming irrelevant, if you use Spark to process a job, first you have to implement it in Scala or Python, and then you have to submit as Spark application. and then it will execute using Spark framework to process the data. It does not use the MapReduce framework. Okay, to use MapReduce framework, a native MapReduce framework, you have to develop the applications in Java, and you have to use MapReduce execution framework to submit the jobs. So these two are tightly coupled. The framework and the programming APIs are tightly coupled. So when we say MapReduce is becoming irrelevant, these two are getting irrelevant. The MapReduce execution framework, which is native to Hadoop, and the MapReduce APIs, which is being developed in Java, are becoming irrelevant. Okay. Even with the MapReduce framework, people tend to develop MapReduce programs using other programming languages such as Python. Even those will become irrelevant with it. We have to learn new APIs which are related to Spark. It could be Scala, it could be Python, or it could be Java also. Even if you want to use Java to develop MapReduce applications in Spark framework, then you have to understand the Spark based APIs in Java, and you have to use those things as a Java developer. But that is not gaining a lot of traction. Spark with Scala and Spark with Python are more important. Okay, so the question you are asking is little bit is due to some confusion. Both the questions are due to some confusion in your mind. Probably that is coming out of the fear of Java. Don't worry about it. Java MapReduce APIs and the MapReduce execution framework, which is native to Hadoop, are getting irrelevant. Instead of that, we will use Spark based applications using Scala or Python as programming language, and we will use Spark based framework to execute the Spark jobs. And when it comes to interviews, even though MapReduce might not be relevant to work on daily basis, still there will be questions with respect to MapReduce. Okay, because people always ask questions that are irrelevant of what you do there. So to understand MapReduce concepts in detail, understanding little bit of Java based MapReduce will help. That's why I'm covering this. And also some people might have the Java experience already. They might want to explore MapReduce APIs also in detail. That is another reason why I'm covering all these things as part of the course. But we'll move on quickly. Probably it will take another class to move on from the Java or MapReduce, and we will start looking into Hive, Scoop, and Spark. So the next question from Gopi is, are you going to take sessions on MongoDB as well? No, those MongoDB sessions will not be part of the course. I will be uploading content on MongoDB on the channel. Okay, Raj said that he actually sent the check. Sure, we will acknowledge once we receive. Yes, so Gopi, to answer your question, Gopi asked me privately, need your guidance to what to learn in Java and what not. That will be clear as part of the next class. We will see basic Java program. If you are feeling comfortable with that, you can actually explore and get into more details so that you can face the interviews more confidently. Do we have class on July 4th, Monday? It's a very good question. It all depends upon your choice. Probably because it's a long weekend, we will cancel that unless everyone are okay to join. Even if one guy says that I have plans for the long weekend, we will cancel that and we will actually have the class on Wednesday rather than on Monday. Okay, I will cancel. Okay, so see you on July 6th. It's a long weekend, so students use this time to explore as much as possible about whatever covered so far, and we will catch up on Wednesday. And as of now, you don't need to worry much other than setting up the development environment and using the CloudX lab, and then we will see the other details about running scoop jobs and all those things starting from the next week. Okay, thank you very much. Have a nice long weekend. Bye.